In this episode, we're going to make one of the most important network ideas much easier to understand, because many beginners hear the names Transmission Control Protocol, TCP, and User Datagram Protocol, UDP, and assume they are dealing with something abstract and hard. The good news is that the basic difference is very clear once you stop looking at the names and start looking at what each one is trying to do. Both are ways for data to move across a network, but they do not handle that job in the same style, and that style matters a lot when something goes wrong. A technician who understands the basic personality of TCP and UDP can listen to a problem with voice, streaming, browsing, or file transfer and make a much better first guess about what kind of network behavior is likely causing the trouble. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at CyberAuthor.me in the Bare Metal Study Guide series. The simplest way to think about TCP is that it cares a lot about making sure data arrives correctly, in order, and in full. If something is lost, TCP wants to know about it and try again. If data arrives out of order, TCP wants to put it back into the right order before handing it over to the application that needs it. That makes TCP feel dependable, which is why it is used for many tasks where missing or jumbled information would create real problems for the user. When a person opens a web page, downloads a file, signs into an account, or sends important information from one system to another, accuracy usually matters more than shaving off a tiny amount of delay, and TCP is built to support that kind of careful delivery. UDP works differently, and beginners often understand it best when they stop expecting it to behave like TCP in a lighter form. UDP is not trying to create the same kind of careful, checked, tracked conversation. It sends data more simply and with less built-in checking, which means it can move information with less delay and less overhead. That makes it useful in situations where speed and steady flow matter more than perfect delivery of every single piece. If a few bits of voice or video data are missed during a live experience, it may be better to keep going smoothly than to stop, wait, and ask for the missing pieces to be resent. That idea is the heart of why UDP exists, and once you understand that, it stops seeming strange that networks would sometimes prefer fast and simple delivery over slow and perfect delivery. One of the biggest points of confusion for new learners is the idea of reliability, because the word sounds like it should always make one protocol better than the other. In reality, reliable delivery is only better when the job actually needs it. TCP includes built-in behaviors that help confirm data arrival, track sequence, and recover from loss, and those features are very valuable when the exact content matters. UDP does not provide that same kind of delivery management at the protocol level, which sounds weaker at first, but it can be the smarter choice for activities that lose value if they are delayed by too much checking and resending. A live call, a fast game, or a real-time stream may feel worse if the device pauses to recover every missing piece. So the right question is not which protocol is smarter in general, but which one fits the kind of experience the user is trying to have. Session behavior is another way to understand the difference, and it helps to keep the explanation simple. TCP acts more like a managed conversation between two sides, where both ends agree to communicate, keep track of what is being exchanged, and notice when something needs attention. UDP is more like sending data outward without building that same kind of careful relationship around every exchange. That is why people often say TCP is connection-oriented and UDP is connectionless. But for a beginner, the useful meaning is this. TCP behaves like it wants an organized conversation, while UDP behaves like it wants a fast delivery path without as much built-in discussion around it. That difference shapes everything else, including speed, error handling, and how each protocol feels when a network is healthy compared with how it feels when the network is under stress. Because TCP does more checking and tracking, it usually creates more overhead than UDP. Overhead is the extra work needed to manage the communication, and while that work is useful, it is still extra work. The network and the devices spend more effort making sure things are correct, ordered, and acknowledged, which can add delay compared with a simpler method. UDP usually feels lighter because it does less of that management at the protocol level. That does not mean it is always faster in every real situation, but it does mean it often helps applications that care deeply about keeping information moving without frequent stops. For A-plus learners, the key point is that the different design choices inside TCP and UDP help explain why one is commonly linked to accuracy-focused tasks and the other is commonly linked to delay-sensitive tasks. Web browsing is one of the easiest real-world examples for understanding why TCP matters. When a user opens a page, signs into a site, clicks through a shopping cart, or loads important information in a business portal, the device needs the correct data and not a broken or incomplete version of it. If parts of the page fail to arrive or arrive in the wrong order, the result can be missing content, bad behavior, sign-in errors, or transactions that do not work properly. That is why browsing is a good example of a job where careful delivery makes sense. Users may still describe the problem in simple terms, like the page is slow or the site keeps timing out, but underneath that complaint is a service that usually depends on TCP behavior, and knowing that helps a technician think about retransmissions, delays, and unstable communication in a more informed way. File transfer is another strong example of why TCP exists and why technicians need to recognize its value quickly. When a file moves from one place to another, the goal is usually not to get most of the file there quickly. The goal is to get the whole file there correctly so it can be opened and used without corruption. A photo archive, a company document, a software package, or an update file becomes much less useful if pieces are missing or out of order. TCP is a natural fit for that kind of work because it is designed to care about complete and correct delivery. If a user says downloads keep failing, transfers are hanging, or a copied file becomes damaged, a technician who understands TCP can immediately see why network loss, unstable links, or repeated retransmission behavior may be central to the problem. Voice traffic helps show why UDP can be the better choice even though it does less built-in checking. During a live voice conversation, the user cares most about hearing the other person smoothly and with as little delay as possible. If a few small pieces of sound are lost, the listener may hear a brief gap, a clipped word, or a slight distortion, but the conversation can still continue. If the network stops to recover every lost piece before allowing the call to move forward, the delay can become far more annoying than the missing sound itself. That is why real-time voice often fits better with UDP thinking. For support work, this matters because a complaint about choppy audio or robotic sound does not automatically mean the network is fully broken. It may mean the network is allowing some loss or delay, and that behavior often shows up first in delay-sensitive traffic like live voice. Streaming video and audio follow a similar idea, although the user experience can look a little different from a voice call. When someone is watching a live stream or listening to real-time media, smooth continuation is usually more important than perfect recovery of every missed piece of data. The user often prefers a small dip in quality or a brief moment of distortion over a long pause that destroys the sense of continuity. That is why UDP-style behavior makes sense for many real-time media situations. At the same time, support complaints around streaming can be tricky because users may simply say the internet is slow, even when browsing works reasonably well and only the live media experience is falling apart. A technician who understands UDP can better recognize that the problem may involve delay, jitter, or packet loss affecting real-time traffic more severely than general browsing or background transfers. One reason this topic matters so much in troubleshooting is that different network problems show up differently, depending on whether the traffic depends more on TCP or UDP behavior. If the network has loss or instability, TCP-based activities may feel slow, stall, or keep retrying because they are working hard to preserve correctness. That can make a download crawl, a web page partially load and then hang, or a remote session feel sticky because the protocol is trying to recover and organize the data. UDP-based activities may not always pause in the same way, but they can sound broken, feel uneven, or look jumpy because missing data is not always resent in the same built-in manner. This is why one user may report that calls sound terrible while another says websites still mostly work, or why streaming may break up even though email seems fine. The technician who knows the protocol difference has a much better map of why those symptoms do not all look the same. Another beginner-friendly way to think about the difference is to compare what the user notices first. With TCP-style traffic, trouble often shows up as delay, retries, waiting, or failure to complete an action. With UDP-style traffic, trouble often shows up as gaps, skips, stutter, distortion, or uneven live performance. That does not mean every single symptom always fits neatly into one box, but it is a very useful pattern when you are under pressure and need a smart starting point. If a user says a file never finishes downloading, a web app keeps spinning, or a login process fails halfway through, TCP behavior should probably be in your thinking. If a user says a call sounds robotic, a live class keeps breaking up, or streaming freezes and then suddenly catches up, UDP-style traffic problems should be much closer to the front of your mind. Beginners also need to avoid a very common mistake, which is treating TCP as good and UDP as bad just because one does more checking. That is not the right way to judge them. TCP is better for some jobs because those jobs need accuracy and order, while UDP is better for other jobs because those jobs need speed and continuity. Both protocols exist because networks have to support many kinds of activity, and not every activity values the same thing. Once you understand that, studying becomes less frustrating because you are no longer trying to memorize a winner and a loser. You are learning two different tools with two different priorities, and that is exactly the kind of practical understanding that helps on the exam and in entry-level support work. It also helps to remember that users almost never describe these issues using protocol names. They do not say TCP seems to be retransmitting too much, or UDP traffic appears to be suffering from loss. They say the call sounds bad, the stream keeps freezing, the web page will not load, or the file transfer takes forever. Your job is to hear those plain language complaints and connect them to the kind of network behavior that might sit underneath them. That does not mean you must become a network engineer to do useful support. It means you need enough understanding to recognize which kind of traffic cares most about correct delivery and which kind cares most about keeping things moving in real time. That one skill helps you ask better questions and avoid guessing at random. By the end of this topic, the main idea should feel much more grounded than it did at the start. TCP is built for careful, reliable, ordered delivery, and that makes it a strong fit for browsing, file transfer, sign-ins, and other tasks where correctness matters a lot. UDP is built for lighter, faster delivery with less built-in checking, and that makes it a strong fit for live voice, streaming, and other activities where delay can hurt the experience more than a small amount of loss. When you understand those two personalities, network complaints start to make more sense because you can see why different services fail in different ways. That is the real value of learning this topic at the A+ level, because it gives you a clear, beginner-friendly way to connect user symptoms to network behavior without getting lost in unnecessary complexity.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.